25 is really 5 squared. So you got to know your powers, your base and your powers here. So we can rewrite this as 5 to the power of 2. And then there's a property of logarithms that allows you to bring the exponent out in front. Basically, this, whatever the exponent is, can come out in front. This 2 is going to come out in front. So this is 2 times log base 5 of 5. This part right here, another property of logarithms, whenever the base is the same as the thing you're taking the logarithm of, this equals 1. So this is just 2 times 1, or 2. That's kind of the long way to do it. You can also use your calculator if you're allowed. I'm not sure if you are. So if you are, I would just go right to the calculator and we can talk about that. I've got a TI 83 if you need me to show you virtually how to do this, but you can see here that this ends up being 0. All right. So you are able to use the calculator. I'm assuming, is that or do you have to show your work?
Oh, we can use the calculator.
Fantastic. Okay. So f of 0, I mean, I'm just going to go right to the calculator if I'm doing that. 0 plus 5. I mean, is that something you want us to spend some time on? We kind of have limited time here today on this. Or can I move right to B?
That would help if we went over it on the calculator.
Sure. Okay. So let me real quick. Do you have a TI 83 or 84?
I have a Casio.
Oh boy. Okay. I am not set up to help with a Casio. So I can look it up. I'm happy to look. What kind of Casio do you have? Model number?
It's, let me check. I think it's FX9750.
Okay. All right. Do you want me to spend a few minutes looking or just move on to part B?
Just move on to part B.
Okay. All right. Yeah. For future lessons, usually I can look real quick and tell you what buttons to push, but it's not considered the traditional calculator for this course. All right. So list the transformations from the parent function. The parent function here, I'm going to grab it one more time, just so we're looking at it here. There are 1, 2, 3 transformations here. Can you name any of them? Do you see any here when you're looking at this?
Is it down 6?
Down 6, good.
Left 5.
Left 5.
And I want to say, I don't know if it's a reflection of.
It's a vertical stretch of 3.
Okay.
Okay. All right. So that's easy enough here. Now, in terms of the graphing, is that, oh, that's at the end. We'll go to that. Yeah. So the transformations, you can always check them in your calculator, which normally I would say, let's go graph it. But if you're ever unsure, you can always graph the parent function, which would be log base 5 of X, and then graph, for example, X plus 5 to see which way it moves if you're ever unsure on a test or a quiz.
Okay.
All right, so let's move on to part C. All right, so f inverse of X, we're going to start with the original function here, y equals 3 log base 5 of X plus 5 minus 6. So I'm not sure if you like cooking or baking, but the inverse is like a recipe. There's step 1, step 2, step 3, step 4. You follow the steps. Some take a little longer than others, but if you do the same thing every time, you'll always get the inverse. So step 1 here is to switch X and Y. So it's X equals 3 log base 5 of Y plus 5 minus 6. I'm sorry, step 1 is to switch X and Y after you replace Y with f of X. So really there's an f of X here. Some call it a step 1. We're going to call this step 1. Step 2, this is the big one. You have to solve for Y. Okay. So this is where most students, if you're not solid in your algebra, you said you're doing pretty well in this class, you're probably pretty comfortable here. We're going to first move the 6 over. We're going to add 6 to both sides in this equation. So it's X plus 6 equals 3 log base 5 Y plus 5. Next is to divide by 3, both sides. All right. And then from here, this is where I guess I want to ask you a question kind of to see where you're at in this part of the course, do you remember how to undo a logarithm, specifically a log base 5?
I don't.
Okay, so it's a little bit odd, a little wonky. You put a 5 here. It's like everything that you just have in this line is the exponent. And the reason it's 5 is because it matches the base.
Oh, okay.
So these things match and they effectively cancel each other. So they go away and you're just left with, on the right-hand side, y plus 5. And then on the left, just kind of written a little better, it's 5 to the power of x plus 6 over 3. Okay. And then subtract 5 as your final step. There's nothing to combine it with, but I am going to put y on the left and this other stuff, the x plus 6 over 3 minus 5 on the right.
Okay.
And then it's kind of a final step, but you're supposed to actually write f inverse of x here. Some teachers are big on that, some are not.
Okay.
Okay, so the next thing is to graph the functions here. Any questions on that though before I move on?
No, I got that.
Okay, all right, great. So we're looking at something like this. Graph both. All right, so it says graph both f of x and f inverse of x on the same graph. The main thing to remember about the inverses when you're graphing them is that they are reflected over the line y equals x. They're kind of a mirror there. So the first one, 3 log base 5 x plus 5 minus 6. We really needed some points to do this properly. It would also help with the inverse. So I think that's probably the best way to do this. Sometimes I talk too much. So if I'm ever going too fast or something isn't clear, just say, hey, Matthew, slow down. I didn't get that or whatever. You're the customer. I don't want to make it I want to make it clear for you. Okay. So, all right. So first couple of points here, talk about why they are the points in a moment. That probably is sufficient. Just trying to decide if you had any other ones there. Okay. So the first thing is it says to label any asymptotes. So the asymptotes occur when the part of the logarithm inside parentheses equals 0. So you're literally setting x plus 5 equal to 0, solving for x is minus 5. So there's a vertical asymptote there at minus 5.
Okay. So would that
question?
So would that be one of the points that I would put?
No, it's just a vertical line. Vertical line. Yeah. The next thing to do is to find nice points to graph, and these were actually points from part A. You see they had f20, f of 0, f of minus 4. These are considered nice points, and we'll talk about why here when we plug them in. So for the first one, it's 3 log base 5 minus 4 plus 5 minus 6. So you can see inside parentheses here becomes positive 1. So log base 5 of 1 is always 0. So it doesn't matter what base it is. If it's 1, it's always 0. So that means the log part is 0. 3 times 0 is 0. Minus 6. So there's our first point to graph there, minus 4, minus 6 roughly.
Okay.
The next one is when x is 0. So 3 log base 5, 0 plus 5 minus 6. Okay, so this time inside the logarithm is log base 5 of 5, which ends up being just 1. 3 times 1 is 3, minus 6 is minus 3. So we got 0 minus 3, something like that. And then 20, I think we did that one as well. 3 log base 5, 20 plus 5 minus 6. That's 25 inside parentheses. It was 5 to the power of 2. We kind of looked at that earlier. It ended up being 0. So there ended up being, way out here to the right, 0. So the asymptote though is key. That's the thing that it comes up from.
Mm-hmm.
So your instructor's looking for something like that.
Okay.
Okay.
Wait, so where'd you get the -4, 0, 20? Like, how do you pick those points?
Yeah, good question. So there's a lot that goes into that. We know certain values of log base 5. We know log base 5 of 1, log
Mm-hmm.
base 5 of 5, and log base 5 of 5 squared, or 25.
Mm-hmm.
So the to answer your question, it's based on the base. It's always 1. You're always trying to get back to 1. You're always trying to get back to the base, and then the base squared. So what we're really trying to decide is, how does, let's look inside parentheses there, how do you get x plus 5 equal to 1, x plus 5 equal to 5, that's the part inside there, x plus 5 equal to 25.
Mm-hmm.
So it has to be a known nice value. Otherwise, it's hard to graph, especially if you don't have a calculator. Is that clear, or do you want more
Yeah,
explanation?
that makes sense now.
Okay, fantastic. Now, in terms of graphing the inverse, we could go back to this mess up here. We actually don't need to. The inverse, I'll just slide this over here to the right. For the inverse, if you recall, you just switch x and y. Remember that from earlier in the course?
Yeah.
So the advantage there is you don't have to do any new calculations. And I think that's the way this problem is designed, is it's like, hey, yeah, you should not redo the calculations here. Because it's not quite to scale, you're looking for, it's got to have some symmetry. So like this -6, -4 over here on the right needs to kind of look, and I'll do it in red, I guess, for this one. It's got to look like it's kind of reflected over that line that I made. And then same with the -3, 0. Kind of looks like that, kind of reflected over that line there. And then 0, 20. Now, there is a horizontal asymptote from this one here that we should also consider. This ends up being another asymptote at y equals -5. So that's, it's a pretty messy drawing. Let's put it kind of right there, roughly. And so the reason that's needed is because you don't want to just show that the exponential goes down forever. It actually flattens out here right at that point. Okay. So not all parts of the problem are created equal, right? That one took a little bit of effort to do.
But you can ultimately use the easiest numbers from the log.
Exactly. Yes.
Okay.
Yes. And you like, if it was log base 3, it's still 1, it's still 3, but now it'd be 3 squared.
Okay.
Or 4, yeah. It's still 1, 4 squared. And
okay.
there's other points too, but that's kind of sufficient, we'll say.
Okay.
All right. So boy, there's a lot for one problem. Show through function composition f of f inverse of x or f inverse of f of x that the two functions are inverses of one another. So you do have to go back to what you started with, which is, I'm gonna just grab it again so that it's clear. There's f of x. Let me go grab our inverse. Hopefully all that'll come down. All right. So you have to decide, do you want to go everything from this one on the right in here, or do you want to go everything from the one on the left into the one on the right? There's no right or wrong answer. You just have to pick.
Probably where x plus 5 is.
All right, just to be clear, what I'm saying is in red, like what we would have, option 1 is to take everything in red and put it in for that x there, or option 2 is everything in blue goes in this x there.
Oh, okay.
You have to pick. It says or, so you choose.
I feel like the red would be easier.
Okay, it doesn't matter to me. They're the same. So, and I don't think one's easier than others. So we're gonna do f of f inverse of x. So the inner one The inner one is the red, and we're putting that in the f. Okay, so it's like this 3 log base 5 of, instead of x, it's 5. Now I'm writing the stuff in red. X
Mhm.
plus 6 over 3 minus 5 plus 5 minus 6. Is that
Okay.
okay? Is that okay?
Yeah. Why do you add the +5? Does it not end at the -5?
It does. The plus 5 comes from the original. This plus 5 is from the
Oh,
original there. Yeah.
okay, that makes
Okay. So now on to just simplifying. Notice inside parentheses there, those cancel. So you're left with 3 log base 5, 5 to the x plus 6 over 3 minus 6. All of this exponent can be brought out in front. That's the logarithm property. We can take everything in green here, bring it out in front. And so it looks like this: x plus 6 over 3 times 3 log base 5 of 5 minus 6. From before, what does log base 5 of 5 become?
1.
1. Yep, good. So this is 1. The 3's cancel. And now you're left with x plus 6 minus 6. The 6's cancel, and you're left with just x, which is what you're supposed to be left with. That's what the instructor wanted to see.
Okay. So, oh, okay. That makes sense. Okay.
All right. Last part here, f. It says show. You already did this. I don't know why I have to show this. All right. So show by analyzing a point that the functions could be inverses of one another. So what that means is, just like you did in the previous I didn't mean to do that. Just like you did in the previous problem here, where you found f of f inverse of x. Instead of x, you now replace it with a number.
Okay.
And it's like, well, what number should you choose? You should choose a nice number. What's a nice number? A nice number is going back to our table. Okay. We want to pick a number on the left here, because this was our inverse that works, because it's going to give us a number over here on the right.
Okay.
So any of these stand out to you? Minus 6, minus 3, 0.
3.
Minus 3. Sorry, that's a minus. Maybe it's not clear. It's a minus. Okay, minus 3. So we're going to do f of f inverse of minus 3. So you again have to go to your inverse function, which is this mess here. Grab that. All right, so you're putting minus 3 in for x.
Oh, okay.
So it's 5 minus 3 plus 6 over 3 minus 5. Minus 3 plus 6 is 3. 3 divided by 3 is 1. It's 5 to the 1 minus 5, which is 0. And if you remember from composition, the output from the inside one, the output, which is 0, becomes the input to f. So you got to go back to your f, which is f of 0 is 3 log base 5, 0 plus 5 minus 6. And you have to simplify this. It's 3 log base 5 of 5. Log base 5 of 5 is 1. 3 times 1 is 3. 3 minus 6 is minus 3. And wouldn't you know it, that matches what you started with. That's the whole point. The whole point is, if you take f of f inverse of a number, or you go the other way around, f inverse of f of a number, you should get the same number. That's why it equals x when you're all done.
Okay. I had a question on how you did the first problem, like the very first one.
Okay, let's go back and take a look here. Talking about this one, f of 20.
Yes.
Okay.
So you just input it and then simplify it?
Yes, that's it. You put 20 in for x.
Well, okay. Never
And
mind.
and same with, 2, 3, 4, 5.
Mhm.
5 is undefined. F of 5.
Okay.
All right. Is that you just sent over? I know one page was like the solutions,
Mm-hmm.
but okay. Do we answer everything you want to talk about tonight?
Yes, you. Oh wait, no, you answered everything.
Yes.
Is there any way where can I access like the video in case
Oh,
I want to?
sure. So let me give me close out here.
Yeah.